All right, whenever you're ready.
Welcome. One of the most basic and useful strategies in problem solving is to break a large problem into smaller parts. The success of this strategy depends on artful and correct reassembly of solutions for the smaller problems into a whole solution for the original, larger problem. This talk presents a version of a famous philosophical puzzle called Zeno's paradox, where we break a problem into very natural small pieces. Each of those small pieces is easy to solve, but the reassembly of those solutions into one big solution goes spectacularly wrong. Understanding the analysis and fixing the part where the logic goes wrong is terrifically instructive, and besides, it's a fun puzzle. Here's the story of Zeno's paradox. All right. This is the story of a foot race between a rabbit and a turtle. The rabbit runs faster, the turtle runs slower. They line up for the race at a starting line. Here they are, all ready to go. Now, if they were just to start this race, it wouldn't be a whole lot of fun because the rabbit would take off and leave the turtle behind. Remember, the rabbit runs faster, the turtle runs slower. So, being sporting, they decide to give the turtle a head start. Here is Zeno's story of the rest of the race. Okay, let's give the turtle a head start. In order to catch up to this turtle, the rabbit must first advance to the point where the turtle starts the race, this head start point. Let's call it point 1. All right, the rabbit's got to get all the way to point 1, but while that's happening, the turtle is not standing still. The turtle is running as fast as it can, and it advances to some new point. Let's call that point 2. All right, the rabbit is now at point 1. The turtle is now at point 2. In order to catch the turtle, the rabbit must advance to point 2. But in order, while that's happening, while the rabbit is advancing to point 2, the turtle is advancing to a new point. Let's call that 3. Here's point 3 along the track. Now the rabbit is at 2, the turtle is at 3. In order to catch the turtle, the rabbit has to come to 3. During that time, the rabbit advances to a new point, 4. And so on. So you can see what's happening now. The rabbit has to pass to point 1, but the turtle advances to 2. The rabbit has to advance to 3, but the turtle advances to The rabbit has to come to 2, but the turtle advances to 3. The rabbit has to get to 3, but the turtle goes to 4. You can see that Zeno is creating an infinite list of points. 1, 2, 3, 4. This will go on forever. More than that, each one of these has a time associated with it. It takes a certain amount of time for the rabbit to travel to the first point. Let's call that time 1. And then it takes a certain amount of time for the rabbit to travel to point 2, let's call that time 2, and then time 3, time 4, and so on. Those are the time intervals, how much time it takes to travel to the next point. So, in order to catch up with the turtle, the rabbit has to pass through an infinite sequence of points, 1, 2, 3, 4, and so on, because every time the rabbit goes to the next point, the turtle's gone on to the next. This never ends. Each one of those costs a finite amount of time. There's time 1, time 2, time 3, time 4 to pass those distances. And so the total amount of time before the rabbit does catch up to the turtle is time 1 plus time 2 plus time 3 plus time 4. We have to add them all up. And that plus goes on forever. Dot, 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 forever. All right, now here's Zeno's reasoning. Because there's an infinite sequence of positive times, time 1, time 2, time 3, and so on, and the total time required for the rabbit to catch the turtle is the sum of the infinite list, time 1 plus time 2 plus time 3 plus time 4. Zeno's conclusion is the rabbit will never catch the turtle. So Zeno's paradox is this argument which obviously has to have a flaw. And the puzzle is to find that flaw. We know that the faster runner will catch up with the slower runner. But Zeno has created a convincing argument that the rabbit has to pass through an infinite list of points, 1, 2, 3, 4, etc. Each of those passages requires a positive amount of time, and the total time required to catch up to this turtle is time 1 plus time 2 plus time 3 plus time 4 plus ... forever. That's an infinite sum of positive numbers. Zeno concludes that must be infinite, and so the rabbit never catches the turtle. So your job is to figure out what's wrong. There's clearly something wrong with the logic. What is it? I'm going to stop here and let you think for a few seconds, see if you can come up with the answer before you turn the video back on. All right, maybe you've been able to think of the answer, and if not, I'll explain how this could work. Zeno's flaw is the statement that an infinite number of positive quantities added together must be infinity. That is not true. And here's an example. We'll start with the number 0.3. To that we will add 0.03. To that we will add 0.003. And then 0.003, ... means continue forever. Every single one of these numbers I've written down, you can see the pattern goes on forever, all positive quantities. It's an infinite sum, but it adds up to something very familiar, 0.333, all threes in a decimal expansion that goes forever. Sometimes that's written 3 with a line to mean continue. And that is the decimal expansion of the very finite and familiar number 1/3. So this is an example of where one of his statements is wrong. He's right about the infinite list of points. 0.1, 0.2, 0.3, 0.4, and so on does indeed go on forever. Time 1, time 2, time 3, time 4, and so on does indeed produce an infinite list of times. But that infinite list of times must be something like this example, where those times, even though there are infinitely many of them, add up to a finite quantity in total. That's the resolution of Zeno's paradox.